Now, our last example is going to have to use some Algebra 1, Algebra 2, where we're going to have to add and subtract rational expressions. So we still have to set this guy equal to 0. So that gives us 1 over x minus 4 minus the rational 3 over 2x plus 1 less than 0. Once we get it set equal to 0, that means we're looking where our function value are negative. The problem is we need one fraction on the left, one rational expression. So we have to add. That means we need to get common denominators. A little bit of scratch work here on the left. We have 1 over x minus 4. The other denominator is 2x plus 1. So we need to multiply the top and bottom of this first fraction by 2x plus 1 minus our second fraction of 3 over 2x plus 1. Well, now that 2x plus 1 is missing our other denominator, x minus 4. So we're going to multiply the top and bottom by x minus 4. Let's distribute the tops. We'll get 2x plus 1. And then we're distributing a minus 3, so that would give us a minus 3x plus 12. Those signs can be a little tricky. So that came from the fact that we had a negative 3 times an x minus 4. And remember, when you're adding fractions, you combine the tops, but you leave the denominators the same. We're going to go ahead and leave these factored, the x minus 4 and the 2x plus 1 in the denominator, since we're going to have to factor them eventually anyway. Let's combine like terms in the numerator. We get a negative x plus 13 over x minus 4 times 2x plus 1. And again, we can bring back down the less than 0. And now we are looking for our x-intercepts by setting the top equal to 0 and our vertical asymptotes by setting the bottom equal to 0. So our x-intercept is where the opposite of x plus 13 equals 0. We can add x to the other side, so we get 13 equals x. Now remember, in our original, it's less than 0, not or equals to. In this case, none of those points are going to be included. So we're going to have an open circle or parenthesis. Then to find our vertical asymptote, we are going to set our denominator, which is already factored, x minus 4 times 2x plus 1 equals 0. So that gives us an x value of 4 and a negative 1/2. Now these denominators are never included. So again, we're going to use an open circle and parenthesis. So let's plot these three on a number line. Again, be sure that they are in numerical order. The negative 1/2 comes first, then the 4, then the 13, giving us 3 intervals to look at. Oh, I lied, giving us 4 intervals to look at. Math teacher, I can't count. So a test value to the left of negative 1/2 could be a negative 10. So we can find f of negative 10. And again, I'm going to focus on the factored form, which was this guy here. The negative x plus 13 over x minus 4 times 2x plus 1 to determine our signs. And remember, this is the opposite of x up here. So if our x is negative 10, that's going to give us a positive 10 plus 13, which is a positive number, over negative 10 minus 4 is negative, times, that would be a negative 20 minus 1, that's negative. So that gives me a positive over positive. Then between negative 1/2 and 4, I would try the point 0. So f of 0, that would give us a positive on top. 0 minus 4 is a negative, and 0 plus 1 is a positive, so that would give us a positive over a negative, which is negative. Between 4 and 13, you could choose anything. I'm going to choose 10, f of 10. So the opposite of 10 plus 13 would still give me a positive in the top. 10 minus 4 is positive. 20 plus 1 is positive, so that gives us a positive over a positive. And to the right of 13, we can choose 100, f of 100. Remember, it's the opposite of x, so that's a negative 100 plus 13. So that's going to give us a negative number on top. 100 minus 4 is positive. 200 plus 1 is positive, so that's a negative over a positive, which will give us a negative number. So we want to know where it's negative. So that's between negative 1/2 and 4. And remember, none of these special values there are included. We don't have the or equals to. And our last interval of negative y values is to the right of 13. So we have two intervals that work. That's parentheses, negative 1/2 to 4, close your parentheses, union, parentheses, 13 to infinity, close your parentheses. All right, so that's it for chapter 3, polynomial and rational inequalities. So just quick recap, set it equal to 0, find your x-intercepts and or vertical asymptotes if you have them, and then check numbers in all of those intervals to see which intervals are positive and negative and satisfy the problem that you were given. All right, thanks for playing. Talk to you guys later. Bye.